Hello students, I am Mr. Rohan Sogle and today we are going to discuss the concept of plasma TV. As in previous lecture we have discussed the concepts of LCD TV, LED TV and their workings. Now let's discuss here in this lecture concept of plasma TV. So basic introduction, in this we are having that whatever plasma TV is there, that plasma TV is far from the science fiction, and this cutting edge technology or cutting edge science can be applicable to everyday's problem. For that, this is the one of the brilliant example. That is, this one is a brilliant example of how cutting edge science can be applied to everyday's problem to make our lives better and more fun. So this is one of the example of cutting edge science. And this plasma screen, it was actually developed in 1960 and was invented or developed by Donald, Herman and Robert. Okay, and they were belongs to the University of Illinois, and as a part of educational computer system called Plato. Okay, and this plasma TV is one of the own invention or illustration of this plasma TV is one of the own invention of Blitzer, and he also filed patent. Actually it was filed in 1966 and it was granted in 1971. So actually this is a patented by Blitzer. Okay, as I said, it was patent was filed in 1966 and he got the grant in 1971. So just we have discussed this plasma. Okay, what is this plasma? We already heard that word plasma TV. What is mean by plasma? Actually, when we study in the college or school, sorry, not in college, when we study in the school, okay, what we heard that basically whatever substance is there, that substance come in three basic flavors or states. Okay, whatever substance is there, that it has three states. Which are that three states? Either solid, liquid and gas. Okay, so these are the three flavors or states. But apart from this, there is a fourth flavor or fourth state, and that state is called as plasma. So plasma is one of the fourth state of substances. Along with the plasma, there is one fifth state is also there, or fifth flavor is also there. It is called as Bose-Einstein condensed state. So this is a fifth step. So we are not going to we are not going to study that in deep. So just concentrate on plasma. So basically this plasma is the fourth state or fourth flavor of substance. Okay, as I said, we know that how solid, liquid and gases are related to each other. Okay, when we whatever substance we are having in solid form, if we heat that, or it get converted into liquid form, and when again that is get heated, then that liquid is get converted into the gaseous form. Okay, so this relation we know, but how this plasma is related to solid, liquid and gases? Okay, so let's discuss how this plasma is related with these three states. Okay, basically as I said, suppose you are having lump of freezing cold ice. Suppose you are have one ice cube. Okay, that is a solid substance. Okay, as I said, if you heat that, or if you heat it up a bit, okay, so it get converted into the liquid form. Okay, when you heat the solid substance or ice, you will get converted into that liquid form, or we can say that as we are having ice cube, it get converted into the water. Again, if we heat it bit more, then soon it will get converted into the gaseous form. Like that we already know. And now suppose, till now we know as substance in solid state, if we heat that, it get converted into, at one stage it get converted into water or liquid form. Again if you heat, it get converted into the gaseous form. Now suppose if we provide more heat to that, then more energy will get injected into that. So again, so the more heat you supply, the more energy you inject. The more energetically the molecules have, the further apart they can push, and they more move about, and more they move about. So if again you provide the more energy, or you supply more heat, then they get more energy and they start moving. Okay, so that we know that. Now suppose whatever liquid is solid is there, or we can consider an ice cube. In that ice cube, whatever molecules are there, initially, as I said, if you provide more heat to that molecules, they get energy, they absorb energy, and they can start moving. Okay, so in case of solid state, or just consider ice cube, in that case whatever molecules are there, that molecules are bonded tightly together. Okay, so because of that substance is in solid form. Okay, and in case of liquid, the molecules are free to move past on other. So in case of solid state, they are bounded tightly with each other. In case of liquid, the molecules are free to move, and in gaseous form, the molecules are completely free of one another and have so much energy that they spread out to fill all the space available. Okay, so it is depends on the molecule. As the molecule absorbs, initially they are bounded tightly. When they absorb heat, the molecules become free and they starts moving. And again, if you supply heat to them, again they get completely free from one another and they start moving, or they start spreading over the space whatever available. Okay, so but what happens if you don't stop there, or what if you keep on heating the gas? As I said, as you heat the liquid, it get converted, whatever molecules there, the molecule absorb the heat and they get free from each other. Each molecules are get free from each other and they start spreading over the space available. But again, if you start heating the gases, then what happens? Okay, so here we are having the answer for that. So the molecules, and that is, if you start again heating the gas, or if you keep on heating the gas, then what happens? The molecules and atoms inside that gas breaks apart and releasing some of their electrons, so they move freely they move freely in and around it. So again, if you start heating, as I said, in that case, whatever molecules and atoms inside that, whatever molecules and atoms are there, they get breaks apart, and because of that, electrons is get released and they start moving freely in and around it. So when atoms disintegrate like this, they form positively charged particle, and these particles are called as ions. You know that. So when electrons get apart, so that atom, whatever atoms is there, that atoms is get disintegrated, and because of that, positively charged ions or positively charged particles are formed, and that particles are called as ions. So the mixture of positively charged ions and negatively charged electrons in plasma turns into a kind of hot soup that will conduct electricity very easily. So this is at a particular stage, whatever gas is that converted into the one type of hot soup, right? So, and as it contains positively charged ions and negatively charged electrons, so they can easily conduct electricity. So this is nothing but plasma. So this plasma, it is a special type of gas in which some of the atoms have become ions. Okay, simple. So plasma, it is a special type of gas in which some of the atoms have become ions. So in other words, we can say that it is an ionized gas. So this is nothing but plasma. If you go on heating the steam or gas, then again electrons and positively charged particles or ions are get apart, and this is a mixture of that. That gas contains the positively charged ions and negatively charged electrons, so that they can easily conduct the electricity, and this is nothing but plasma, or you can also call it as a ionized gas, right? So then let's see how this. So this is a basic concept of plasma. Then let's see how this plasma TV works. Now suppose you just imagine that if you build a TV screen out of millions of microscopically tiny CFL or neon lamps. Okay, you are having one TV, or you have built one TV which contains millions of CFL and neon lamps. Okay, which could be switched on and off very quickly. So as we know that as image changes, accordingly we have to make the CFLs or neon lamps and on and off, and it could be switched very quickly and as per the requirement, and it can be controlled by the electronic circuitry. So you just imagine you have built one TV with millions of CFL and neon lamps, and that you have to make it on and off very quickly as necessary. Okay, so that's pretty much how plasma TV works, and it's very different to other kinds of television technology. The pixel cell in plasma TV have things in common with both neon and CFL lamp. Whatever plasma TV we are using, or whatever pixels we are using in a plasma TV, they are having some common things which are there in neon lamp and CFL. So what are the common things we are having in pixels of plasma? So let's see what are these common things. So in case of neon lamp, we know that in case of neon lamp, each cell is filled with a tiny amount of neon or xenon gases. Okay, we know that these lamps contain neon or xenon gases. And in case of CFL, each cell is coated with the phosphor chemicals. And in case of CFL, due to this phosphor chemical, whatever phosphor is there, the phosphor is a chalky white inside on. In a CFL, a phosphor is a chalky white coating on the inside of the glass tube, and it works like a filter. Okay, so there is one white coating is there inside this glass. In case of CFL, okay, chalky white coating is there inside the glass tube, and it acts as a filter. So in this case of CFL, when we pass the electricity, or when electricity flow in that tube, the gas atom crash about inside it and generates invisible ultraviolet light. And due to this due to the white phosphor coating, whatever invisible ultraviolet light is there, it gets converted into, or it turns into visible white light. Okay, so this is a basic thing related to CFL. In case of CFL, we are having the coating, and it is actually white coating is there. When we white phosphor we have used, when we pass the electricity, it generates the invisible ultraviolet light, and this white phosphor coating, it turns the invisible light into the visible white light. Okay, so this is in case of CFL. In case of plasma TV, the cells are bit like tiny CFLs, only the coating with phosphors that are red, blue and green. Okay, so in case of plasma TV, whatever cells they have used, they are similar to the tiny CFLs. Okay, small CFLs are there. It are like small CFLs, but the only difference is that in case of CFL, chalky white coating is used, but in case of plasma TV, we have used red, blue and green color coating. So their job is to take the invisible ultraviolet light produced by neon or xenon gas in the cell and turn it into red, blue or green light. Blue light we can actually see. So same, what is use of this small tiny CFLs having red, blue, green coating? So simple, their job is simple. They simply take the invisible ultraviolet light which is produced by the neon or xenon gas, and they turn that invisible light into visible red, blue or green light. So this is the use, or this is the job of these tiny CFLs which are used in plasma TV. So how this actually works, how we get this light. So let's discuss the actual working of this plasma TV or plasma screen step by step. Okay, so here I have shown one plasma screen. This is a plasma screen. Okay, here red, blue and green pixels are there. Again red, blue, green pixels. Okay, so we'll discuss step by step. So this is the first. Much like the picture in a LCD screen, the picture is made up by plasma TV. Is made from an array of red, green and blue pixels. Okay, as I said. Okay, this we are having. Okay, just look over here. This is the array of pixels of red, blue and green color. Okay. Right, and each pixel can be switched on or off individually by a grid of horizontally and vertically mounted electrodes. So here we are having electrodes which are mounted horizontally and vertically, and because of that electrodes, each pixel can be made switched on or off. So here, okay, if you look, these are the horizontal grids we are having, and these are the vertical grids we are having. Okay, and with the help of this horizontal and vertical grid, we make each pixel on or off. By passing the electricity through this grid, we make each pixel on and off. So here I have shown one zoom image of a pixel. Okay, so what I have shown, okay, suppose we want to active one of the red pixel. Okay, so here as I showed, I have shown one pixel. This is a red pixel I have shown. Okay, so suppose I want to on this red pixel. So how I am going to on this red pixel? Okay, by supplying electricity to this and this grid. Okay, this sixth vertical grid and ninth horizontal grid. Ninth horizontal and sixth vertical grid, if we provide this supply, and because of that this pixel is get turned on. So how it is get turned on? So let's see. So the two electrodes leading to the pixel cell put a high voltage across it. So as I said, sixth and ninth, okay, horizontally electrode, ninth number horizontal electrode and fourth number vertical electrode. Sorry, not fourth, I think it is sixth one. Okay, ninth and sixth. Okay, if we provide the high voltage to these two electrodes, okay, so because of that it causes the ionization and it emits the ultraviolet light. Okay, so as we provide the supply to these two electrodes, due to that two electrodes it causes the ionization, and due to that it emits the ultraviolet. So this is the ultraviolet light I have shown. So due to that ionization we are getting this ultraviolet light, right? Okay, and this invisible ultraviolet light shines through the red phosphor coating on the inside of the pixel cell. As I said, we are having the pixels of red, green and blue color, and accordingly we have provided the red, green and blue colored phosphor inside that. So here this is a red color we have provided, or we have added red colored phosphor inside this pixel. So because of that, as ultraviolet light shines through this red phosphor, and because of that we get the red colored coming out of this pixel. So the phosphor coating converts this invisible ultraviolet into visible red light, making the pixel lights up as single red square. So as I said, due to this ultraviolet light, it strikes on that red colored phosphor, and due to that we are getting the red colored light. Okay, so this is simple working. In this way we can on green colored pixel, blue colored pixel, and according to the position of pixel we have to provide the high voltage supply to the electrodes. So this is a simple working of this plasma strain. Okay, I hope you understand what we have discussed till now. So simple, we have discussed what is plasma, who invented this plasma. Then again that we have discussed that is what is plasma. This is actually fourth flavor or fourth state of substance. Then how we are getting this, that we have also discussed. Then again we have discussed the how it is similar to the or what are the common things used in plasma TV. Okay, so what are the common things in the neon lamp and CFL which are used in plasma TV, that we have also discussed. And again we have discussed this working, how each pixel is turned on and off in case of plasma strain. Okay, here I have shown the image for the same. Okay, so I hope you understand this concept. So we'll stop over here, and next part we'll see in the next lecture. Okay, thank you.